All right, here we go again in section 4 now, solving systems using elimination. This is the last method that we have to solve a system of equations. In the next section, we're going to talk about systems of inequalities. But let's get into elimination. This process is to add the two equations together in order to eliminate one variable, hence the name elimination. Okay, remember in substitution what I was trying to do was to get an equation so it only had x's or only had y's in it. That's what I'm going to be doing here, is I'm going to add the two together so I can eliminate an x or eliminate a y. Okay, I must have the same variable, meaning the x in the first equation and the x in the second equation, or the y in the first and the y in the second. It has to have the same coefficient, but it must have opposite signs. So a 2x and a negative 2x, or a 5y and a negative 5y. And we'll see here in the next couple examples, there's lots of different ways to go about doing that. Okay? So if I look here at example 1, if I want to talk about the steps real briefly when trying to decide which method to use, we talked about graphing is when both are in slope-intercept form. Neither of these are in slope-intercept form. We said in substitution that we wanted one to be solved for a variable or one that didn't have a coefficient. Both of these have coefficients. So what I'm going to do is use elimination. And I notice if I look at my y values, I have the same variable, I have the same coefficient, but I have different signs in front of them. So what I can do is add these two together. And I'll do x's together, y's together, and then my answers. So 3x plus 2x gives me 5x. Negative 5 plus positive 5 cancels out. Negative 16 plus 31 is a positive 15. From there, I now have an equation. 5x equals 15, for which I can divide by 5 and get x equals 3. Now, just like with substitution, I then have to take this 3 and plug it back into one of my equations. I'm going to choose the bottom one because it has positives and it has smaller numbers. So I'm going to plug that back in there. So I'll have 2 times 3. Oh, too many parentheses. 2 times 3, because I plugged in 3 for x, plus 5y equals 31. Now I'm trying to solve for y. So 2 times 3 is 6, plus 5y equals 31. Subtract my 6, 5y equals 25. That means y is equal to 5. Okay, so both ways, I got a single answer here. Okay, x equals 3, y equals 5. Just like with all of our other methods, there are ways that you're going to end up getting no solutions or infinite solutions, and we'll see those. Actually, we're not going to see those in our example here, but it works the same just as substitution. Okay, if your variables cancel and you have a false statement, it's no solutions. If your variables cancel and it's a true statement, you then have infinite solutions. So sometimes we will need to multiply each equation by a number to make the variables match. We can see in the second example that none of my coefficients are the same. I have a 3x and a 5x, a 4y and a 2y. I don't care about the number or the answers, but my x's and y's are different. Okay, so I need to think for a second about what I can do to make the equations look the same. And if you think, I can multiply this bottom equation by negative 2. What that's going to do is allow me to make this 2y into a negative 4y, because that's what I want. I have a positive 4y. If I get a negative 4y, my y's will cancel. So we're going to multiply this whole equation by negative 2. And over here, I'm going to rewrite the whole problem just because it's going to be easier. So 3x plus 4y equals 6. Now I multiply the bottom by negative 2, so negative 2 times 5 is negative 10x. Negative 2 times positive 2 is negative 4y. Negative 2 times negative 4 is positive 8. That's the easiest thing to do. Easiest mistake to make is forget to multiply your answer by a number also. So now when I look at this, I see that I have variables matching up. So I know a plus 4y and a minus 4y cancel. And 3x plus a negative 10x gives me negative 7x. 6 plus 8 is 14. Now I can solve for x. Divide by negative 7 so that x is negative 2. Take that negative 2 and plug it back in. Okay? You now have 3 different equations to choose from. You can choose from this equation that you made, this equation that you started with, which is also over here, the same equation, or you can go to this original equation. Okay, and plug it into any of those. I would probably choose the first original, 3x plus 4y equals 6, because there are no negatives and they're relatively small numbers. So I'll take that x equals negative 2, plug it in for this. So 3 times negative 2 plus 4y equals 6. And now I'll solve for y. 3 times negative 2 is negative 6 plus 4y. Add 6 so that 4y equals 12. Divide by 4 so that y equals 3. And there's our solutions. X equals negative 2, y equals 3. Okay? Again, these are very long problems. I understand that. It's a lot of steps, and so you have to stay organized. Okay? You might need to watch these 2 or 3 times over so you can get everything that's going on in them. Okay? Please don't be afraid to ask questions over these. This is a very difficult thing. The substitution and elimination are very long processes. We're not used to doing problems this long. So please don't be afraid to ask questions and watch these videos as many times as you need to. Okay? So now in example 3, we notice that, again, none of my variables match up. My x's don't, my y's don't. And the difference here is I cannot just multiply one equation. I can't turn my 2 into a 3 or my 3 into a 4. I'm going to have to multiply both equations by a number so I can get them to match up. So I need to think kind of back to things like fractions. Think about the least common multiple. And if I do that, I can see I can make this 3 and the 2 into a 6 very, very easily. Okay? So I can multiply this top equation by 2, because that's going to make my x value a 6. Then I would need a negative 6 on the bottom for my x value, so I'm going to multiply that by negative 3 to make that a negative 6. Okay? So I'm going to go through and multiply now to get 6x plus 8y equals negative 50. The bottom equation, I'll get negative 6x. Negative 3 times negative 3, don't miss that, is a plus 9y. And then negative 18. Okay? When I add these two, my x's cancel. That's how we designed it. 8 plus 9 is 17y equals negative 68. I only have one variable, which is good. That's how I wanted it. So that y is equal to negative 4. Okay? Now, what do I do with the y? I plug it back in. Again, this time you have 4 options to choose from. 1 right here, 2, 3, or 4. Any of those equations you can choose. I will probably pick the second one here because it has small numbers. Small numbers are easier to multiply. So we'll do 2x minus 3 times negative 4 equals 6. Negative 3 times negative 4 becomes a positive 12. So I'll subtract 12. 2x equals negative 6. Divide by 2 so that x equals negative 3. And there's our two answers. Okay? Whew. So I know that was a lot. Feel free to rewatch this. Again, I cannot stress that enough. Watch this as many times as you need to. Ask as many questions as you need to in class. This is a very, very long process to go through. It's not difficult. It's just a lot of steps and a lot of stuff to do. Okay? So now we have a summary here of when to use these three methods. On the test, all you're going to be given is a bunch of systems, and you're going to have to decide which one to use. Okay? So I want to use the graphing when both equations are in slope-intercept form. That's always going to be the best time. Okay? Substitution, if one variable is already solved for. Okay? And then elimination, you're just going to use any other time. All right? So that's the end of section 4. Again, we have section 5 coming up next with solving systems of inequalities. There's only one way to do that, through graphing. And so we'll take a look at that when you get around to it. I'll see you guys later. Bye.